Okay, Lucas, I'm going to try to explain how to do the recursive equation if I understand the video correctly. So I'm going to do I think this is a quadratic equation because the first difference would be a -3, right? And then, whoops, we're not going to put it there. The difference between 9 to 6 is -3. The difference from 6 to 5 is -1. The difference from 5 to 6 is 1, and the difference from 6 to 9 is 3. So then we need to get our second difference, and the second difference is 2, I think. So from -3 to -1 would be a +2. From -1 to 1 would be a +2. And from 1 to 3 would be a +2. Okay. All right, so then it appears that to write the recursive, you need to be able to remember the explicit equation for the linear difference. And so when we're writing it, we're going to write f of n equals so like if we have 9 and we want to find 6, if we didn't know, or we want to find the next one after we go 1 2, we want to find the 3 value down here. What number do we write down here? We go backwards. We find 9 and we do something to 9 to get the number down here. So it's going to be f of n equals f of n minus 1, which means if I'm trying to find this value down, in fact, let me see if I can do that. So if I want to insert a row below, let's say this is 3. If I want to find this value right here, then I am going to, when I have f of n minus 1, it means I'm going to go back to 9 to find this question mark down here that I don't know. Okay. I don't want to highlight that guy. Okay, so to find this guy, I'm going to go back to 9. That's what my f of n minus 1 means. And then I need to add something. Whoops. I'm going to add something to it. And he was saying put this, what you're going to add, which is what I don't know yet. I'm going to put it in parentheses. And according to the video, they were saying that that's because this right here changes. Okay, so we want to figure out what we put in there. And what I was told is what goes in there is the explicit equation for the linear difference. So what goes in here, we'll go ahead and just like highlight this. I don't know, we can make this little peachy color right here. What goes in here is the explicit equation of the linear difference. So we got to write the explicit equation for this, for this right here. What's the explicit equation for this right here? So what's the explicit equation for this? That's what's going to go in there, okay? So then the explicit equation, if you remember, for a linear equation, because that first difference is linear, is y equals mx. Hold on. Go take a shower. Y equals mx plus b. Okay? That m is your change. Okay? So if we're looking at this, and this is the change that's happening for these numbers, the difference between them is this change. Well, the change is a 2. So this is your, actually, I'll just use this one. This right here, this m is your, that's your rate of change, which is a 2, okay? Because your rate of change is right here. So we have part of our explicit equation that we need to put in there. It's going to be, since we're using n's, we could use an n instead of an x. So part of what we need is 2n. Wait a minute, where'd it go? Okay, so part of that, because what we need is this right here. That's what we're looking for. And part of that is going to be 2, and I'm going to, instead of write it as 2n, I'm going to write it 2x, which I could go ahead over here. I'll just make this an n instead of an x. So we have 2n. Then we don't know, what we don't know is here. What do we put here? What's the b part? Okay, so then how do we calculate that? Well, what he was suggesting is that we actually plug in some numbers and see if it works. So we have that y equals mn plus b, or really what it is, where'd that little box go? Is y equals 2n plus something, right? Plus something we don't know. Okay, so we're going to take and we're going to plug in some numbers to that. So let me just take it again. Okay. So what he suggests is actually taking a number from here and seeing if it works. So if we take, let's say we do this line right here, and I can highlight that, I don't know, like this blue color, okay? We're going to take this line right here, okay? So our x value is 1, and our f of x is 6. And remember, f of x is the same thing as y. So I'm going to put 6 right here, okay? And then I am going to put this in as, okay, ignore the 6th part. We are going to see if it equals the change. So we are going to do, sorry, we're still going to use that row, but what we're going to do is the change is over here, it's that 2. So we want to, if we use 6, if 6 is our, we want to plug in 6 as our x value and see if it gives us that change. Okay, so we are going to, goodness, I can't get in here. Okay, so we are going to take our 2, and in that n value, we are going to put our x value, which is a 1, and then does that give us the rate of change, which is our second difference? Okay, so it does. We're going to try another one. So let's do 2 times 2. Does that equal... No, I'm doing something wrong now. Hold on. I did something wrong. Hold on. So we are going to take that x value. So we have that 2 in, and we're going to take an x value. We're going to take, let's do the 1. So we're going to do the 1. And then we want to see if it equals our first rate of change, which was a 1. It does not. In order to get to 1, we have 2. It's got to be minus 1. So then we can try it again also. 2 times the 2. If we plug in the 2 value, it should equal 3. It doesn't. It equals 4. To get to 3, we're going to minus 1. So that's what we put up here as what goes here. In order to get these values to actually equal what's in this column. So when I plug in my x values over here, if I put 2 times 1, I get 2. I don't get 1. If I put 2 times 2, I get 4, not 3. How do I get to 1 and 3? I do 2 times 1 minus 1 gives me 1. 2 times 2 minus 1 gives me 3. So what goes over here is a negative 1 or just a minus 1. And that is what you take and put back up here. Okay? And that is how, so that is the recursive equation. This is the recursive equation for this quadratic equation. Okay? So let me see if I can maybe I can do another one. Okay, so let's try with this one. So the first difference to go from 4 to 0 is going to be a minus 4. To go from negative 4 to negative 2 is going to be a positive 2. To go to a negative 2 from a negative 2 would be a 0. To go from a negative 2 to a 0 is a positive 2. Then another positive 4, and then a positive 6. That would be the first difference. Then we have to calculate the second difference. A negative 4 to a 2 would be a plus 6. I had one wrong. It should be a negative 2 here. So this is 2, 2. Okay, so I've calculated so these are the numbers that I was given. This is my first difference. This is my second difference. Okay, so again, I want to calculate the recursive. And so basically when I'm calculating the recursive, my goal is to figure out this right here. What is this number? That's what the recursive is going to tell me, the next number in my sequence. Okay, so when I'm doing the recursive, it's going to be f of n equals, and so in order to find that question mark, I'm going to go back to 10. I'm going to go to the term before, and I'm going to do something to it to get that number that I want to know, that question mark. So that 10, or any one that comes next, is f of n minus 1. That just means going back a term. So to find the next term, I got to go back one term. So f of n minus 1 plus something. What am I going to do to that term to find the next one? And so again, what we were told to do is this. What goes in here is actually the explicit equation of the linear difference. So remember, we're going to write the explicit equation for these numbers, and that will help us figure out the rest of our recursive equation for our quadratic. Okay, so remember that the explicit equation is f of n equals mn plus b. Okay. Okay, so we are going to find our change. Our m is a 2. So I am going to, again, just go ahead and write that right here. So part of the equation that goes in there is going to be 2n. 2n. But then I need to know, what do I add to make it true? Okay, what do I add so that I will be able to calculate the number? That's what I've got to figure out. So what you were told to do is take an x term, which is your n. So your n or x, you're going to take one of these and you're going to multiply it by 2 and see if it gives you this over here. So like if I do this one right here, if I do 2, okay, so let's say I do that, I'm going to do 2 times 2, I'm substituting that in with 2, and that equals 4. But what we want it to equal is 4. Okay, so then that worked. So I could try it again just to make sure, and I could do 2 times 3, and we want that to equal 6. It does, so that means there's nothing, I don't think there's anything that we add here. So what goes in here is just going to be 2n plus 0 plus nothing. So it's just going to be 2n. So this one's f of n plus 2n is how you get the equation for this. So that's how you do these recursive equations.